And here we are once again. In our last video about various organic functional groups, we're going to focus in on what we call carbonyl groups. The hallmark of a carbonyl group is a C double bond O. One of the groups that's attached to what we call the carbonyl carbon is almost always something for an R group, something for a carbon chain. It's going to be what's on the other group, the other side, that really defines what the carbonyl is. And so what I mean by that is if we remember sort of our basic Lewis structures and Vesper types of shapes, if we have a C double bond O, then there's two of the bonds that carbon can make right there. So carbon is going to be able to form two other bonds. And so one side is just going to be whatever, and anything for this big long carbon chain. It's what's over here that's going to define what the carbonyl is. Is it just a hydrogen over here? Is it something for another R group? Is it an oxygen? Is it an alcohol? Is it even something maybe for an ether group? Is it a nitrogen? So all sorts of different groups that could be over here on this other side of the carbon that really will define what the carbonyl is. And again, remembering back to our Vesper geometry, that also means that the molecular geometry around the what we call the carbonyl carbon is always going to be a trigonal planar geometry there. So review your Vesper principles if that doesn't ring a bell. And so this is exactly what I was just saying. And so in order to determine what type of carbonyl we have, we want to really be looking at what is over here on the other side. And so these are the basic types of carbonyls that we're going to be looking at. If that's a hydrogen on the other side, we call that an aldehyde. If it's another carbon with another sort of R group over there, that's called a ketone. If it's an OH, that's a carboxylic acid. If it's an O with another R group, so that would be sort of an ether, so we'd have sort of a carbonyl here and an ether here. That's called an ester. Or if we have a nitrogen with whatever hanging off it on the sides here. Could be H's on the sides here, could be R groups, could be whatever. But if we have a nitrogen hanging off that other carbon here, that's called an amide. And it's usually pronounced like that, not amide. We usually say that's the pronunciation of that is typically amide. And so as I go through these, I'm going to talk about the naming rules and I'm going to show some examples, but know that I'm not going to hold you responsible for naming carbonyls in the same way that I am going to hold you responsible for hydrocarbons, alcohols, and thiols, not on this list. Ethers and amines, basically everything that I talked about in the other lecture, absolutely you're going to have to know how to name those and be able to come up with names of those compounds. I'm not going to make you do the same with these carbonyls that we talked about, but I'm still going to go through the rules and look at some of the structures because I do expect that you will be able to identify the type of carbonyl from either looking at the structure or seeing the name. And so you should be able to see something like pentanal and know that that is an aldehyde. I won't necessarily expect you to draw it, but you should know that is an aldehyde, which is our first group to talk about. So aldehydes have a hydrogen attached to that other side of the carbon. When we're naming aldehydes, very, very similar to how we've named other organic compounds. We look at the root, we assign our ending, we assign prefixes. The key here for us is that the ending for aldehydes is that ending al, al. Aldehydes are pretty reactive, but they are found quite often in nature in various types of organic compounds. So here's just a few examples here. So 3-methyl pentanal. And so when we're naming aldehydes, the carbonyl carbon is always number 1. And so that takes care of worrying about any numbering locator numbers for our carbons. So here's our 1 carbon, 2, 3, 4, 5. So pentan, al tells us that it's an aldehyde. And we have a 3-methyl substituent group. 4-methyl pentanal, so same 1, 2, 3, 4, 5. So it's pentanal. and a substituent group of a methyl at the 4th carbon. 2,4,5 trimethyl heptanal. Again, don't necessarily worry about the structure and the naming, but recognize that if you saw this, you should know that's an aldehyde because we have a C double bond O with an R group, and this is a hydrogen here that's just not shown. So that's an aldehyde. You should also be able to just see this name and say, oh, that ends with Al. That compound must be an aldehyde. Ketone is the second group. Now, instead of a hydrogen on that other side, it's going to be something for another R group. Ketones are found everywhere through nature. Yeah, I was going to give some examples there, but I'll hold off on that. The big thing with ketones, as far as their naming, they end with the name one, O-N-E. So some examples here, 2-heptanone. So now we do need to include a locator number to tell us where the C double bond O is. So here we would have heptane, 1, 2, 3, 4, 5, 6, 7. And our double bond O is coming from the second position, so 2-heptanone. 6-methyl 2-heptanone. So the same compound, but now we have a methyl group coming off carbon 6. 6-methyl 4-propyl 2-heptanone. So again, the same thing, but now we have a propyl group coming off our 4th carbon. Now in this one, all we've done is we've shifted our carbonyl group to the 4th carbon, sorry, to the 3rd carbon instead of the 2nd. So these two actually are identical, but we've moved our carbonyl group from here to here. So we get 6-methyl 4-propyl 3-heptanone. Remember, though, what I really need you to know from this is to be able to look at this structure, to be able to look at this and say, okay, there's a C double bond O, so I know it's a type of carbonyl. And in this one, I've got 2 different carbon groups coming off my carbonyl carbon. So the type of compound that this is a ketone. You also need to be able to look at this and say, oh, okay, 6-methyl 2-heptanone. Without seeing the structure, if you saw just the name, you have to say, okay, 6-methyl 2-heptanone that ends in O-N-E must be a ketone. Carboxylic acids. Carboxylic acids are found everywhere in nature and biology. In a carboxylic acid, the other side of that carbon group is going to be an OH. That's going to be an alcohol over there. So we see several examples here. Here we have hexanoic acid, and that's the key in carboxylic acid naming is the name is oic acid. So here we have 1, 2, 3, 4, 5, 6 carbons. Then our C double bond O to an OH. And so hexanoic acid. And a few other examples here. So this is the key determining factor of a carboxylic acid is the C double bond O to an OH. So if you see this, know that's a carboxylic acid. If you see something that ends in oic acid, carboxylic acid. Something called fatty acids, which we'll talk about when we start looking at biomolecules in probably next week's lectures, actually. Fatty acids contain long unbranched R groups. And we find carboxylic acids on there. Amino acids, which will form probably the basis of at least one whole lecture. Amino acids contain a carboxylic acid, and they contain an amine in there. There are some compounds that have multiple carboxylic acid functional groups. Carboxylic acids, it should also be noted, are very capable of hydrogen bonding, which plays a big role in some of their properties. Esters. In an ester, we have our carbonyl group, and then we have coming off that an oxygen, and then another R group coming off of that of some sort. So that's an ester. The ending of esters is O8. You can see that here. O8. So a few just different examples here. Ethyl hexanoate. Again, here's our carbonyl functionality here, our C double bond O, coming down to an O with another group coming off of that. And so you would be able to recognize this structure as being an ester. You would be able to recognize these names as being esters because they end with O8. Esters do have a permanent dipole, but they can't hydrogen bond because there are no hydrogens attached to an oxygen. Esters are found throughout nature. The fragrances in different fruits and flowers, and some of the characteristics of triglycerides. But for instance, the smell of something like a banana, it's because of some of the various ester compounds that are in there that give us that characteristic smell. And finally, I think this is the last one. Yep, finally, amids. So amids have our C double bond O, and then they have something for an amine group hanging off that. So same idea, we would assign our root for our main chain. Our ending here for amids has the ending amid. So a few different examples. We have hexanamide, N-methyl hexanamide, N-ethyl and methyl hexanamide, and so forth. And so what do I want to say here to wrap this up? So again, really the big thing with the carbonyl groups is being able to just recognize what type they are, and from either looking at the name or the structure. And the reason that we need to be able to identify these and see these is that there are several of these that are going to come back to us when we start talking about some of the biochemistry topics to close out the course. When we start looking at the structure of things like amino acids, we're going to need to be able to identify the carboxylic acid group and the amide group in there, because those are going to interact with each other and play a role in a lot of the different things that we talk about. When we talk about fatty acids, we're going to need to be able to see the carboxylic acid group and what that's going to do. And so we introduce them here so that later on when they come up in the course, you're familiar with them. And when I say the carboxylic acid over here on this side of the amino acid, you'll know what it is that I'm talking about. And so that is it for this shorter video, not as long as some of the others. And so I hope you've enjoyed watching as much as I've enjoyed recording. Have a great day, everybody.